Okay, to talk about the triangle inequalities here. Looking at from my site here, I talked about, imagine you had lengths, like stick lengths here of 3, 4, and 5. So imagine these are your lengths. What you'll find is that we already know 3, 4, 5 is a triangle because it's a right triangle. In fact, that's a right angle right there, because 3 squared plus 4 squared does equal 5 squared. But just to show you, the reason that this does form a triangle is because any two sides, any two, are always greater than the third. Okay, any two I pick are always greater than the third. Okay, and that's the reason that this will form a triangle. You'll see what happens when I have 3, 4, and 7. Okay, this next set. 7 ends up being equal to 3 plus 4. So hence, you'll see it actually ends up forming a straight line here. It's impossible for this to be an angle right there. And so it couldn't form a triangle. It's just two linear segments, which is not by definition a triangle. And so the 3 or 4 has to be slightly larger in order for it to form a triangle. Okay. Same thing if it's less. If it's less, then it definitely can't form a triangle because it can't even connect with the end there. And so the only satisfying requirement here is that it is going to be greater. Okay, make sure that it's greater than the third. So let me show you some examples here. And let's say I had segments here, and I had a blank, and I had 3, and I had 5. And I said to you, what are the possibilities for the third side here, the one that's a blank right now? Well, I know here that two sides have to be bigger than the third. So right now, okay, 5 and 3 have to be larger. When I add those two up, they have to be larger than this guy right here, than the third. Which means I can't have a segment that's bigger than this. If it's a whole number, okay, if all these are whole numbers, 5 and 3 add up to 8. And 8, okay, when I add up 3 plus 5, I end up getting 8. And 8 is larger than 7. And that's okay. So one value for this could be 7. Now, in fact, that's the largest. That's what we call the maximum size of this. Okay, that's the maximum size. What's the minimum size of this? Well, the minimum, let's see here, would be, well, I know that, well, the blank, this one, plus 5 has to be greater than 3. So right now, if I pick, the first and the last side, they're bigger than 3 no matter what, because 5 is already bigger, so that's not going to have any effect on this. But if I look at the other scenario and say, well, something plus 3 is greater than 5. Okay, that has to be true. In other words, the first and second side has to be bigger than this third one here. When I look at that, my only possibility is, well, if I pick 2, okay, 2 plus 3 is actually equal to 5, it's not greater. So if it's a whole number, it's going to be 3. And that, in fact, is my minimum value. That's the smallest that this can be. The biggest it can be is 7. The smallest this can be is 3. And it can be anywhere in between there. Okay, so this third side here could be 7 to 3. And so, in fact, if I call that x, x is less than or equal to 7, and it's greater than or equal to 3. That's the kind of range of these. Okay, that's the smallest value, and that's the biggest. And anywhere in between will satisfy this as a triangle. Let's take a look at some more examples here. Suppose, I'm going to just erase all this here. Suppose I have a new example here. Okay, and the new example said, I had a blank, comma, I don't know, make it 5, comma, and 12. Okay, what's the biggest this value can be? What's the maximum size? Well, the maximum size would be, well, let's take a look. 12 plus 5, okay, is when I add up to two sides. That has to be bigger than this blank. Well, 12 plus 5 is, let's see, that's 17. So that has to be bigger than the blank. The biggest this can be is 16 if it's a whole number. That's the biggest. Okay, the biggest this can be is 16. What's the minimum though? Okay, the minimum, I take my same idea again. The minimum, okay, I'm going to look at, for the minimum, pardon me, for the minimum, I'm going to say that, okay, well, something plus 5 has to be greater than 12. Again, I don't check something plus 12 because that's already bigger. But this has to be bigger than 12. Okay. Well, what number would that be? Well, the smallest that this number can be, Okay, if I make it 7, it's not bigger than it, it's actually equal. So the smallest it can be is 8. So in other words, my range here is going to be, the minimum is going to be 8, and this is my max. Okay, and you kind of go through it and look at it like that. Now, a couple problems you're going to get is when they change things up and they say things like, well, if you look at that last problem, suppose I had 5 and 12, and in this blank, okay, I had x plus 2. So that was the variable. It just says x plus 2 in there. Don't change any rules. What I'm going to do is I'm going to ignore this x plus 2 and just treat this whole thing as like a variable y. Okay. Well, what's the biggest value of y? Well, we found it out to be, well, the biggest, I'll call it y max, is equal to 16. What was y minimum again? Okay, that whole number for that third side was, sorry, I believe it was 8. Is that right? Yeah, that's 8. So there's the minimum, there's the maximum. Now, if they want to know what is x's minimum and maximum, well, if this is going to equal 16, if x plus 2 is equal to 16, what's x equal to? Well, the biggest x can be is 14, because that way this whole thing is 16. What's the smallest x can be? Well, I know x plus 2 is equal to 8, so the smallest will be if x is equal to 6. So while this number, the biggest it can be is 16 and the smallest is 8, x can be 14 or 6. Keep in mind that this whole thing is a number. That's what it actually is, okay, when you're doing a problem like that.